Hello and what's up to you all pre-matriculants. It is a lovely Tuesday and you know what that means. It means it's physical sciences time. My name is Abram and I'm here to help you guys through with our teacher along. But very importantly, you need to get your notes. All our notes are on lan.mindset.co.za. Even if it's last week's notes, you can still get them on the very same link. It's very important and very short, lan.mindset.co.za. But for today's show, we'll be posting the notes link on facebook.com/learnextra. It is also where you can get to chat with other mindsetters, help other mindsetters, and then hashtag walk with us because we're here to walk with you guys. On that Facebook page, we have over 77,000 mindsetters, which really means that we are a big family that is there to help one another. On the links that will be on Facebook, we'll also have the test yourself links with questions that when you answer them correctly, you stand a chance of winning this awesome Casio calculator, proudly sponsored by Casio. And I'll be telling you the winner from last week's show. It is a cool it is a cool calculator that you can get yourself. It has about 254 functions. How cool is that, mindsetters? And the nice part of it, it's the answer memory, which you don't have to memorize your previous answer when you're using this Casio calculator. You can just use the previous memory button and then get the answer, the previous answer. But otherwise, we also have a challenge question for you guys, which also is posted on facebook.com. When you go to our wall, you get to see the challenge question, and I must advise you guys, you must answer on the post that is on Facebook. Last thing that you need to know before we get on the lesson is that we have a help desk that is dedicated to help you guys. All you need to do is to go to apps.facebook.com/learnextra. The link of the Facebook of the help desk is also posted on Facebook. So guys, make sure that you go to our Facebook page and also follow us on Twitter @learnextra. But now let me welcome our teacher, Mr. TK. Say, how are you?
Good, and you, Abram?
I'm also good. Say, you know, it's a lovely day. It's Tuesday and it means physical time.
Tuesdays are always lovely days because physical sciences come to the rooms of all the learners that are doing physical sciences there. And here I am, TK is here to take you through a lesson on gases, grade 11. So you stay there, you go nowhere. Now, do you want me to just take it? And
You can take it away, sir.
just
What we're
have the
doing
lesson
and help the
started.
mindsetters.
Okay, now Abram has agreed that I actually take the whole of this time talking to you or introducing this lesson to you. Like I said, we're talking about gases or continuing our lesson on gases. And today, specifically in this lesson, I will be explaining to you some gas laws, and we will be defining and explaining what we call Boyles law. We will also look at Charles's law, and we will also do calculations, of course, based on both the laws, that of Boyles and that of Charles. So we will be doing those calculations there. Now, moving on, here is our challenge question for the day, and please note it and begin to work on it. A fixed amount of helium gas has a volume of 180 cubic centimeters at a temperature of 30 degrees Celsius. The pressure of the gas is then adjusted from an initial value of 100 kilopascals to 80 kilopascals. So you have reduced the volume, okay? Whilst the temperature is kept constant, of course, at 30 degrees Celsius. Calculate the volume. So what is needed here is for you to calculate the volume that the gas will occupy after the pressure has been adjusted, after all those adjustments have been made. That's your challenge question. Let's move on. Okay. Now, gas laws. What we need to know is that with gas laws, these laws gives us the relationship between the physical quantities of a gas, which is the temperature, pressure, volume, and of course, the number of moles of the gas, or the quantity, how much of this gas we are having. So that is actually what the laws do to us. They put together those quantities and then see how they relate to each other. Okay. Now, when a relationship between any two variables amongst the temperature, amongst these variables, which is temperature, pressure, and volume, Okay, when they are investigated, other variables must be kept constant. And variables that are kept constant, scientifically, we call them controlled variables. Okay, so if you keep one variable constant during a practical investigation or practical experiment, that variable is called the controlled variable for that practical. That's very important for you to note. All right, now coming to Boyle's law. Boyle's law gives us the relationship between the pressure of a gas and the volume of the gas. Okay, and what does it say? Now, all these, go and read it. It's part of your notes. You download the notes like Abraham was saying, and you read them. The law says the pressure of a fixed amount of gas is inversely proportional to the volume provided, now this is a condition, provided the temperature remains constant. Now, I want you to see the two variables that are kept constant here, or what we call the controlled variable for this particular law, gas law. In the first place, it says fixed amount of gas. So if it is a fixed amount of gas, it means the quantity of the gas. The quantity of the gas. Quantity, it's constant. Cool. So that is one variable. But down here, where it says provided, it also continues to tell us that temperature is constant. So the quantity of the gas and the temperature of the gas are the controlled variables when we're looking at Boyle's law. All right, so that is very critical. When the temperature is kept constant for a fixed amount of gas, the average kinetic energy of those gas molecules will of course remain constant or remain the same. When the volume of the container in which the gas is kept is decreased, the space for the gas particles to move around becomes smaller, okay? Hence, the rate at which the particles collide with each other and also colliding with the surface of the container increases. Now, when that rate increases, then the pressure of the gas increases, okay? So it is an inverse relationship, so it tells us mathematically that pressure is inversely proportional to volume. When multiplied by K, this proportionality here, what we get is that P is equal to K over V. The proportionality is for us to remove the proportionality sign. And therefore, when you work out this such that K becomes the subject, PV equals to K. And for all positions of whatever curve you're going to produce here, you would find that the PV equals to K remains the same. K is a constant. It remains the same. So P times V is the same throughout. Therefore, what it means is that if we find the values of P and V at one point, which we'll call it P1 and V1, those values of P and V at the second point, when we multiply them together, they should be equal to the multiplication or the product we'll get when we have P1 times V1. So P1 times V1 equals P2 times V2, because all of them equals to K, the constant, okay? Right, explaining this a little further, the unit of measurements for pressure, we know that, pascals from previous lessons. Cubic meters are the SI unit for volume, okay? But you need to be aware that other units of measurement are used. For example, with pressure, we do use kilopascals as well. With volume, we do use cubic centimeters as well. And because this is multiplication and division, when we're calculating, it doesn't matter much as to whether you're using kilopascals or pascals, cubic centimeters or cubic meters, right? And for real gases in all everyday scenarios, a compression or reduction in volume or an expansion, increase in volume, always results in a change in the temperature. So we actually, remember, we're looking at an ideal gas mostly. So usually when you do this, you're gonna change, the temperature changes, but we're saying keep the temperature constant. Moving on, looking at Charles's law. Now, Charles's law focuses on the relationship between what we call the absolute temperature and the volume of a fixed amount of gas. Now, what are the variables that are kept constant here? Again, you hear fixed amount of gas. So we're talking fixed quantity, okay, of gas. So the quantity is a controlled variable. The next thing is that if we're looking at temperature and volume, what is the other thing? It would mean that the other variable, which is of course pressure, will be kept constant. And therefore, for Charles's law, these two become what we call, let me use this part here because I have space. These ones become what we call the controlled variable. The variables that are kept constant in a practical investigation are called the controlled variables. Okay, now what does the law say? Charles's law says the absolute temperature is directly proportional to the volume of a fixed amount of gas, provided pressure and the gas amount, the amount of the gas remains constant. So this would say, and the amount of the gas, of course, remaining constant. All right, now, what does this mean? If you talk about absolute temperature, okay? If you talk about absolute temperature, you're talking about the Kelvin temperature, okay? Where we know that the 0 degrees Celsius does not become the absolute zero. So 0 degrees Celsius is not absolute zero when we're talking Kelvin temperature, because that 0 degrees Celsius is actually plus 273, and that gives you 273 Kelvin. Okay, so it's not absolute zero. So what will be absolute zero? Absolute zero will be minus 273 degrees Celsius. Okay, so let me erase that. 273 degrees Celsius. What am I doing here? So degrees Celsius. Okay, so what that means is that if you do the Kelvin, the degrees Celsius there, and that being the volume, so this is temperature versus volume, you would find that your absolute zero is there. So this is where the Kelvin scale starts. That is it's very important for you to see. Now, explaining the law itself, just making use of how we did it with the Boyles law, look at it. We're saying that volume is directly proportional to absolute temperature, the Kelvin temperature. So we say that V would be equal to, so we remove the proportionality sign again by the constant K. V equals K absolute temperature. Now, V equals K absolute temperature. It would mean that K is equal to V over T if we want to find K, which is the constant. Okay? And that, if you work it out, because if V over T is constant at every point, in this, for example, in this graph that I've drawn here, if V over T is constant throughout, it means that if I take 1 point there and 1 point there, so V1 for this point 1, that will be point 2. V1 over T1 should be equal to V2 over T2, because all of these gives us a constant K. So we arrive at that particular formula there. So that gives us, if you like, the theory behind the laws of gases as propagated by Charles and Boyles. And therefore, from this, we will be able to use these laws to actually find or solve problems that come around. Okay, so let me emphasize before I hand back to Abram the issue of the absolute temperature. Okay, absolute temperature. This point in a graph here, this point here, we call this the absolute zero. Absolute zero. Because we have a zero there, we have a zero here, which is 0 degrees Celsius. But then when we perform this practical and we plot this on a graph of temperature versus volume, which is that, we find that the volume occupied by a gas when the temperature is 0 degrees Celsius could be a value at some point, as you see it on the graph. But when we proceed, because we are interested in finding where this graph or this line is going to cut across the horizontal axis, which is the temperature axis for this case. When we follow it up, we get to a point where we find that point there, that where there is zero volume. It is zero volume when we have got absolute zero. This will be 0 Kelvin. And at that point, it will be minus 273 degrees Celsius. That is the point I was talking about earlier on. Let me hand back to Abram for now. You have a bit of a breather, then we come back and continue with the lesson.
Awesome, thank you, sir. And a big shout out to all the mindsetters that are watching, such as Zitgobile Dlebe, who says, I'm watching the show, and a big shout out to all the grade 11 class of Eben Donges, and also a shout out to Sanele, who's saying, Hala at Team Mindset. Please say my young brother's name on TV, Kilebokhele. Hi. And I know that Ilebokhele is the 11-year-old. Sanele always says on Facebook, I'm watching the show with my 11-year-old brother. I hope he's the one, Kilebokhele. But otherwise, mindsetters, after the break, I'll be announcing our Test Yourself winner from last week's show. So stay tuned. Welcome back, Pre-Matrix. Now, it is the time where I announce the winner. But before I announce the winner, let me tell you how you can also become one of the winners. All you need to do is to answer the Test Yourself questions, get most questions right, or all of them correctly, and then you stand a chance of winning this awesome Casio calculator. Our winner from last week's show is Sifiso Ntlapo. Congratulations to Sifiso Ntlapo. You've won yourself this awesome exam toolkit that you need to always have, because it's exam time now, so you need to always have your calculator. But otherwise, Mr. TK, I'm one person who likes to make deals.
Oh, yeah. Okay.
Do you also love deals?
You want to make a deal with me?
I want to make a deal with the mindsetters.
Okay, with them, not me.
With them.
Okay,
You don't
no,
like
that's
deals?
Fine. No, I don't like deals. Okay, that's fine.
Okay.
Go ahead.
If you like deals, mindsetters, I have a deal for you. I saw a lot of you guys saying I should send them shout outs on the page, but my deal is the only way I'm going to send you a shout out, it's when you're asking us questions. So that's a simple deal.
I
right?
love the deal. That's
simple.
one kind of a deal I would always
Because it's going to help you at the end of the
support,
day.
yeah.
It doesn't help me saying your name only, but you need to ask a question and then help other people that are watching as well.
Great.
Thanks,
I
sir.
love the deal. Thank you so much,
Deal.
Abraham. Now, let's move on, and now we're going to look at exemplary questions, questions that you can expect from question papers, and something that can help you practice. You see, that's how much Learn Extra loves you, gives you practice questions so that you can actually get ready for your exams and other things. Let's just have a look at this one here. The first question is question number 1. We're talking about, let me just read it first. It says 1,000 cubic centimeters of gas at a pressure of 100 kilopascals is kept in a sealed container at 25 degrees Celsius. Okay? It continues to say the volume of the container. So the volume of the container is increased. Oh, so volume is one of those quantities that is fiddled with here, such that the pressure of the gas decreased, okay, to 80 kilopascals. This sounds more like Boyles law. Okay, so I'm trying to think of which equation, which formula am I going to use? The way I'm reading it, it sounds more like Boyles law. I'm reading volumes changing, leading to pressure changing from one value to another, but I'm told there's a temperature here. But let's read and find out about this temperature. It says, when all these things are happening, the temperature remains constant. Now, this is definitely Boyle's law, because with Boyle's law, we keep temperature constant, we control that variable, and then check the others. We control the temperature, we control the quantity. We don't add or remove anything from the quantity of the gas. So let's see how we're going to deal with this then. So this means that if I'm to calculate for the volume, okay, calculate the volume of the gas. If I'm to calculate for the volume, it means I would say pressure. Oh, let me just do it this way, writing down what is given to me. P1 is given to me as 100 kilopascals. P2 is given to me as, it changed to 80 kilopascals. And V1, I was given 1,000 cubic centimeters. And V2 is what I need to find out. So that's what I need to calculate for. Right. Now, I use Boyle's law because this is based on Boyle's law, which says volume 1 pressure 1 times volume 1 should be equal to pressure 2 times volume 2. Now, I think every science teacher that speaks to you always say this, that if you have got a formula to work with, the best thing to do is to substitute into that formula without making what you are looking for the subject of the formula before, because that makes sure that even if you have or you make a mathematical error along the way, at least you have all the marks in terms of the substitution. So I will continue to teach you like that and say substitute. I'm told here P2 is 80, so I write here 80 times V1. It's given to me as 1,000. Okay, this should be equal to P2 is given to me as 80 times V2 is what I'm looking for. All right, so I would have that. So at this point, I did that so that I can get marks for that substitution. And of course, I would have earned a mark for writing down the right formula to use for this calculation. Therefore, from there, I would know that V2 equals, what is P1 here? Oh, made P1, I think we made a mistake with P1. I'm seeing my mistake now because I'm looking at that. P1, it's 100. So this is 100 kilopascals. Okay, so that is 100 kilopascals. So we actually made a mistake there. So this 80 here should be 100. Okay, that's my P1. That's my P2. So that's what we have. So V2 will be equal to 100 times 1,000 divided by 80. And what is that? So let's work it out. We do have a calculator here. Work it out. So we've got 100 times 1,000 divided by 80. What do we get? 1250. Okay, so this is 1250 what? Cubic centimeters. And it makes sense because we have actually reduced pressure, so volume had to increase. That is Boyle's law. That's what it says. The two are inversely proportional to each other. That is the kind of relationship that they have. So that's why I like science, because once you understand the rule, when you make a mistake in your calculation, you check your answer against the law itself and you see, hey, something is wrong here. Suppose I got the volume to be decreasing as the pressure decreased. Something would have gone horribly wrong in my calculation, because then that would not be supporting Boyle's law. So that's one thing good about science. Right, now moving on to the next one. Okay, we're looking at question number 2. Question number 2 says, an amount of gas is heated under constant pressure. Constant pressure. This sounds more like Charles's law. Okay, Charles' law sounds more to what I'm reading here. So that its temperature increased from 25 degrees Celsius to 30 degrees Celsius. The volume of the gas at 30 degrees Celsius is 150 cubic centimeters. What was the initial volume of the gas? So I need to find V1, initial volume of the gas. Because I am given V2, I am told V2 is 150 cubic centimeters. All right. But then, what other variable has been given to me here? I'm given temperature. I'll use small letter t for it. And those of you who remember last week's lesson, you remember that you use small letter t there for gases in talking about temperature when you're talking about degrees Celsius kind of temperature. Because with the Kelvin temperature, we use capital letter T. So I'm given this temperature in degrees Celsius. So I'm told that T1 is 25 degrees Celsius. T2 is 30 degrees Celsius. But it is very, very important for you to know that Charles' law speaks about absolute temperature. Absolute temperature. Okay, so we're talking about absolute temperature. So if you are given temperature in terms of the degrees Celsius, you would know that you would need to convert that into the Kelvin temperature to be able to do your calculations correctly. For your calculations to be correct, you need to convert this. Therefore, down here, it means I would say my T, capital letter T, which is absolute temperature, will be 25 degrees, will be 25, sorry, don't want to even see degrees there. That will be 25 plus 273 Kelvin. So what I have as my T1 is 298 Kelvin. The same thing this side. T2 would be 30 plus 273. That is how we convert to absolute temperature. So T2 equals that. So that equals 303 Kelvin. Okay, so these are the two values of the temperature that we are going to use here, because, let me emphasize it, we can't use the degrees Celsius scale here because the law is based on the Kelvin temperature. So then we will be able to say pressure 1 over volume 1 will be equal to pressure 2 over volume 2. What am I asked to find out? I'm asked to find what the initial volume is, V1. I have V2 and I have T1 and T2. So let's substitute into this all these values. Okay. P1. What did I do here? This should have been T1. Sorry about that. I think I messed up here. We're talking Charles' law. So these are your temperature 1 and temperature 2. Okay, good. So now, what is your temperature 1? Temperature 1 is 298 divided by volume 1 is what I am looking for. Temperature 2 is this one here, 303 Kelvin divided by volume 2. What is volume 2? We are told of volume 2, 150 cubic centimeters. So we put that in, 150. All right? Therefore, my V1 equals, can cross multiply now, 298 times 150 divided by 303. I am not bound to use this step. I'm just helping you. This step here is not really necessary for me. I can go straight to the answer, but I'm just showing you, especially those that are battling, to see where all this come from. So let's see, with the use of the calculator, what the answer is going to be. Okay, so this is 298 times 150 divided by 303. And what is the answer? The answer works out to be 147.52 cubic centimeters. So 147.52 cubic centimeters. Oh, what a cubic centimeter value is that? So cubic centimeters. Now, that is the answer for that one. Emphasizing it again, because I know it always evaporates out of our mind most of the time. When you're dealing with Charles' law, temperature should always be in absolute values, which is the Kelvin temperature scale. Convert, if it's given to you in temperature, in degrees Celsius, convert from degrees Celsius to your Kelvin temperature. Okay, so we need to always do that. I will deal with the challenge question, but I just want to check, Abram, if you have some questions there. Maybe we can begin to deal with them as we move on, and then later on we look at the challenge question and also deal with more questions that are from the mindsetters out there.
I'm sure.
Yeah.
I have a few.
have a
Tabo,
few.
actually, it's a lot.
Okay.
But I think we can take a break, and then after the break, when
All
you
right.
are fresh,
think so,
we
yeah.
can take all of them.
Oh, good. That's fine. That's a brilliant idea. Let's
Cool.
have a
Deal.
bit of a breather.
Deal. Well,
There
my
and
sisters,
there.
we'll see
Yeah.
you after the break. Welcome back, my sisters. Now it's straight to the questions that you guys have asked us on facebook.com/LearnExtra. TK, are you ready?
Very ready. Very ready. Let's just have the questions now.
Okay, first question, it's from Resejo saying, aren't we supposed to change, sorry?
Yeah.
Sorry, it's Landis was saying, AP, can you please ask for me, aren't we supposed to convert V1 into DM3?
Oh, okay. All right. It's not necessary when you're dealing with these equations here. In both Charles and Boyles' law, with that volume, it's not necessary to change it. Why? Because you're changing it by the same factor. Let me just show you with the first one here. Say you're looking at this one here of calculating for the for V2, the very first question we looked at. You would see that this is the volume. This is your volume. It is in cubic centimeters. And your volume this side would also be found in cubic centimeters. Why? Because even if you change this one you convert this into cubic dm cube, you're going to multiply that by 1,000. So a factor of 1,000. And let me, for the sake of space, just you convert this by actually dividing by 1,000. I mean, dividing by 1,000, which will be dividing by. I made a mistake here, so let me take that out. So you are dividing these cubic centimeters to change them into dm cubed by 10 to the power 3, by 10 to the power minus 3, all right? Or what am I doing here? Let me just get this one right. Okay, so you either dividing by 1,000 or multiply by multiplying by 10 to the power minus 3. This is the same as dividing by 1,000. This side, you are also going to multiply by 10 to the power minus 3. So what is basically going to happen is that because this is an equation, this equals that. And this is multiplication and that is multiplication. If I have 10 to the 3 on the left and 10 to the 3 on the right, I can actually cancel that out. And that is the reason why actually converting is not so necessary. This is the same thing with pressure. If you want to change pressure from kilopascals to pascals, okay, what are you going to do? You're going to multiply both sides. You multiply both sides by 10 to the power 3. So even this side is going to multiply by 10 to the power 3. This is when we're talking about pressure now. And because 10 to the 3 is both on the left and on the right, you can actually do away with that. So that conversion becomes, does not affect your calculation. So that's why you don't have to go to the SI units as such. But when you come to Charles's law, the conversion from the degrees Celsius to Kelvin becomes necessary. You have to do it. Why? Because there we are not multiplying by 273. Okay? We're not multiplying by 273 or dividing by 273. So that in both cases, you can say you have got a common factor. But what are we doing there? From T, we add. So when you're adding, the reciprocal or the additive inverse of adding is minus. You can only deal with those. If you have got division and multiplication, okay, the two are reciprocal of each other, so you can play around with them. So with the Charles's law, when it comes to temperature, you can't say, I can work in degrees Celsius. You always have to move from degrees Celsius to Kelvin.
Okay, quickly
Yeah.
before we go to the challenge question,
Yeah.
two questions relating to that same question.
Okay.
Pamela says, how do I know which one is P1 and P2? And Karabo Silemela saying, I think you've made a mistake. You substituted P1 twice. It's 1,000.
Oh, okay. I think Karabo didn't see what's happening here, but just a quick correction for Karabo. Karabo, if you look at these here, the P1, the pressure one, was 100 kilopascals, and the volume one was 1,000 kilopascals. So there is nothing wrong there. Maybe because we used the 100 and 1,000, you didn't really see the other zero there. So this way for pressure, 100, volume, 1,000 cubic centimeters. So that's what was happening. So there's nothing wrong there. You can continue with that calculation. All right.
The other one, how do you know which one is P1?
How do you know which
P2?
one is P1? That is definitely having to do with how you read your question. You need to read the question. You need to know, the question will tell you. Let me just put it that way. The question will tell you that the first pressure was they won't say first pressure was, they will tell you maybe pressure changed from this value to that value. So this value then becomes your P1, that value becomes your P2. As good as that. Let's just quickly do the challenge question and see how they were supposed to work it out. The challenge question is saying, let's have a look at it. A fixed amount of helium gas has a volume of 180 cubic centimeters at a temperature of 30 degrees Celsius. The pressure of the gas is then adjusted from an initial value of 100 kilopascals to 80 kilopascals whilst the temperature is kept constant. Calculate the volume that the gas will occupy after the adjustment. Oh, okay. This is actually more or less the same question that we did. It's unfortunate that it had to come back as our challenge question, but perhaps because people asked a lot of questions, let's go back to it. Maybe it's an opportunity to re-emphasize it. You can write down all the values that are given to you. And for who is the guy that asked about how do I know this is the first pressure and the second
Silomela.
pressure? Yes.
It's a lady.
Let's read this question again and see. Pressure, okay, it says a fixed amount of helium gas has a volume of, so that becomes your V1. It has a volume of 180 cubic centimeters. So that is V1. The pressure of the gas is then adjusted from an initial value of 100 kilopascals. Okay? So from an initial value, that tells you the first P. So P1 equals 100 kilopascals. Then, when it is adjusted from that initial value, it now got to a value of 80 kilopascals. So that is P2. Okay. So you see now how we identify our P1 and our P2s. Calculate the volume of the gas. So we're looking at V2. Then you go and use the equation as is. And remember, we have done this. So the best thing will be to go back to your questions there, Abram, and see how many are asking and what do they want to know.
Okay. Best Kid says, if the volume of gas is increased at constant temperature, what happens to the pressure?
If the volume of it?
Of gas is
Yeah.
increased at constant temperature.
Volume of gas increase, constant temperature.
What happens to the pressure?
This is Boyles' law, okay? If volume of the gas increases, pressure decreases. The two are such that they are inversely proportional to each other. You increase the one, you decrease the other. That's what Boyles is saying, and that has been proven. As long as you keep the temperature constant and you make sure that the amount of the gas that is there is kept constant as well. So you're not adding, you're not removing any amount of the gas from that container.
Okay.
Yeah.
Bongilwaz Nkosi says, since Charles' law says temperature in kelvins is directly proportional to volume,
Yeah.
do I have to change the temperature to kelvins when doing questions relating to Charles' law?
We have emphasized that there is no way that you can work out any solution based or using the degree Celsius temperature. You have to always use the Kelvin temperature for that particular calculation with Charles' law. So it is the absolute temperature that has a relationship, the direct relationship with the volume. So you have to always use the Kelvin temperature.
Okay, Bongilamin says, firstly, hi Abram, I'm enjoying the show. And please say hi to the grade 11s from Abel Mutwane High School. Hi. And the question is, how do we calculate pressure and volume if you are not given the values using Boyles' law?
Okay, there's no way that they can ask you without giving you the values. There has to be some values at some point. Otherwise, they may say at standard temperature and pressure, which is what we call the STP. And I think some of the people might have asked about this. So here, standard temperature is 0 degrees Celsius, and obviously that will be 273 Kelvin. Or looking at standard pressure is always 101.3 kilopascals, or what we call 1 atmosphere. But you are not going to use 1 atmosphere in your calculation. You're going to use that. So that's the only time I can think of when you're not given values, but you're given standard values.
Okay, let's take the last one, talking about standard values.
Yeah.
When we talk of constant pressure and temperature, is it the same as standard pressure and temperature? And also send out a shout out to Khakola class of grade 11C. That's from Tabunkos.
Okay. Now, well, good question. When we talk of constant pressure, we don't mean this pressure. We don't mean this one. We don't mean the standard pressure. Constant pressure, it can be any value. By constant, we only mean it remains the same. So if it is at 20 kilopascals, it's 20 kilopascals throughout. It is controlled. It's a controlled variable, and other variables are being changed and having an effect on others. That's what is happening.
Okay.
Yeah.
Last question. Why not? Because I had over 61 questions.
Oh, okay.
All right. This one is from Sanele Mtamo.
Yeah.
She thinks this one it's quite an easier one. How do
Yeah.
we convert Pascal to kilopascal?
Okay. Pascals to kilopascals, if you have got, you always divide by a factor of 1,000. So, or you say multiply by 10 to the power minus 3 when you are dividing, when you are converting pascals to kilopascals, okay? And when you are moving from kilopascals to pascals, then you multiply by 10 to the 3 or multiply by 1,000. That's how you convert. But most of the things you will be doing won't need you to do those calculations or those conversions, but know them.
Okay, awesome. Thank you so much, sir. That's where we have to end it. Let me end it with, because I'm a nice guy, just one shout out. A big shout out to all the learners from Chibasa Secondary School. I hope you started your day well and you're enjoying the show. That's from Mulalo Prudi. Tandavatu. Tandavatu loves people. Muraro Prudi.
Yes.
Tandavatu.
Thank
She
you,
loves people,
Muraro.
eh?
Yeah. Okay. Thanks, Muraro, and everyone else that has been watching. And from me, Tinyiko Kosa, TK, it's a bye-bye.
Thank you so much, guys. Last words from me, guys. Never ever wish that life was so easier, but rather just wish that you could face the challenges better and tackle them in a better and smarter way. Otherwise, we love you. From me, AB and TK and the rest of the team. Peace.